The arc on and off action is a nice, steady buzzing sound. The weld puddle area shows very little spatter. If the open circuit voltage is increased to 35 volts, there is excessive spatter, and the arc sound is now sharp and rasping. The load voltage during welding goes up to 26 volts. The bead has an irregular ripple, and the edges of the bead suggest poor fusion. Lowering the open circuit voltage to 20 provides a load voltage of 12 or 13. The deposition of filler metal is irregular. The weld joint has a high crowned bead. Very little penetration is achieved. Rather, the metal deposit is mostly on the surface. When proper conditions are achieved, the bead is properly flat, but not concave or rounded inward, and spatter is minimal. Too high voltage produces excessive spatter and a very irregular bead. Too low a voltage shows spatter plus an irregular, excessively high bead, suggesting very poor penetration. It becomes apparent that operator skill must be developed in setting the proper voltage for each welding condition. It is a matter of experimentation, and soon becomes a skill now possessed by thousands of welding operators in industry. Actually, it is seldom necessary to change the slope of the volt-ampere curve for short-circuiting metal transfer in mild steel welding, since the manufacturer will have set the slope to handle most of the conditions encountered. But a competent operator should know how to get the most performance out of his power source. Setting the slope of the volt-ampere curve is extremely simple. The volt-ampere curve is merely a method used by welding power source manufacturers to illustrate on a graph the electrical energy output in volts and amperes of a welding power source. The volt and ampere output values of the power source form points on the graph. When a line is drawn through these points, the output curve is formed. The voltage indicated and its correlation or joining with an amperage value simply states that the power source is capable of providing that amount of voltage at the indicated amount of amperage. Power sources, such as the 250 ampere constant potential or constant voltage machine in use here, offer the opportunity to control the amount of maximum short circuit current and its rate of response. This graph illustrates that if there were no control over the current, it would simply surge to a very high amperage, far beyond the design parameters of the power source, until the wire electrode literally exploded. Without control over the amount of current, the clearing of the short circuit as the wire touches the work is violent. An intense spatter occurs. The extreme heat is causing the remaining electrode wire to melt or ball up prior to the short circuiting or touching to the base metal. Note the arc reigniting with great rapidity. There is not enough time for a smooth transfer of molten metal. The entire action is literally out of control.